All right, you guys. So now that we have spoken about some of the key behaviors that gases exhibit, we want to talk about how these things are actually influencing what we see. So, how does pressure influence things around us? How does the amount of gas and the fact that it has mass influence things around us? Okay, so we're going to kind of dive into the relationships between pressure and volume and temperature and amount of gas and atmospheric pressure now. You're going to get a lot of practice with kind of multiple choice style questions. Some of them are built into your notes, some of them are not. And so it might not be a bad idea to jot down some of these examples if multiple choice are something that you think that you need to focus on. Okay. This is also going to tie back heavily into the lab activities we did the other day. Part of your work for today is going to be analyzing your lab and seeing like, okay, was pressure involved in this? Was volume involved? Was temperature? Was atmospheric pressure? And was the amount of gas? So you'll be analyzing, did those 5 things influence what you saw in each of those stations? So was pressure involved when the can crushed? Was temperature involved when you pumped the soda bottle 100 times? Was air pressure, atmospheric pressure involved in putting the marshmallow in the syringe? Things like that. So make sure you're taking good notes through this. This is going to be sort of carrying us through this unit are these concepts here. So let's go, let's get ready, and let's get focused. All right, so this first part says that pressure is going to depend on temperature. But before we kind of really dive in, we need to understand what temperature really is. We think of it as just this like number, and it's warm or it's cold. Temperature is the amount of energy in a sample. Okay, yes, there are way more fancy definitions. But for us, what I need you to understand is that temperature is going to directly relate to energy. Okay, so temperature is defined as the amount of energy in a substance. And that temperature is going to directly relate to energy. So this next statement says, therefore, the higher the temperature, the more energy the gas particles have. So if you think about you, right, like when you have a lot of energy, you're more likely to move around. And when you don't have a lot of energy, you kind of want to stay put, right? So when you are moving around, like if everybody in the classroom started running around, it's very likely that we would bump into each other, therefore exerting pressure. Whereas if we all are just sitting still, which is most likely what's happening right now, you are not bumping into each other and you are not having collisions and you are not exerting pressure. So here we go. This statement, therefore, the higher the temperature, the more energy the gas molecules have. Let's break it down. High temperature means high energy. High energy means high movement. High movement means more collisions. More collisions means more pressure. Okay. So this statement, right? Pressure depends on temperature. Right there, that's why. So if you need to, rewind and hear that explanation again, because it's a big one. So I want you to think about this question now and go ahead and submit which of those statements, justifications, is going to be the best. Okay, so as you read through this, the correct answer should have been A. Okay, as temperature increases, the energy increases. So the particles are moving faster, so they have more collisions. And then boom, 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 big idea, more pressure. Okay, so now I want you to go ahead and think through this one. Okay, so for this one here, the lower the temperature, the lower the pressure. So here we go. Here's our explanation. Low temperature, low energy, low movement, low collisions, low pressure. 5-point answer to that. Okay, so again, low temperature, low energy, low movement, low collisions, low pressure. Okay, so there's your 5 parts for that. And that's really going to help you in your explanations. You'll get some practice with this for homework and in class. There'll definitely be short answer styles like this moving forward in the unit. So make sure you feel good about that. So the answer to that is true. Right, so here we have an example of tire pressure. So in some of our really cold days, it's really likely that if you have a car that has a automatic pressure checker that you might have a little indicator light go on in your car, or you may even have a digital screen that says check tire pressure. Or my car even shows like the number for all 4 of my tires. So for example, one of mine this morning was setting off an alarm that it had low tire pressure. And again, this is because it was cold outside. The gas molecules in the tire had low energy. Because they had low energy, they were not moving around as much. Therefore, there were not as many collisions. Therefore, they were not exerting the right amount of pressure. I had low pressure in my tire. Okay. So yes, making sure we're feeling very good about these definitions. Okay. Pressure depends on volume. So this is another one. It says you can change the pressure exerted by a contained gas by changing its volume. So the statement here reads that more gas is compressed, meaning you're decreasing the volume. One thing that I've noticed students struggle with the word volume is they're thinking of like the volume of the gas, meaning quantity. No. Make a note to yourself somewhere in your notes that volume is referring to the container size. Okay, so is your container this big, or is your container this big, or is it this big? All right. Volume is referring to container size, not like quantity. So the more gas is compressed, aka decreasing its volume, the less space there is for gas molecules to move. All right. So here we go again. We're going to break this down and get our big idea relationships for pressure relating to volume. Okay, so take a beat and here we go. So gas molecules are spread far apart. When the volume is decreased, the amount of empty space goes down. Therefore, the gas molecules are more likely to bump into each other and have more collisions. So the pressure is going to increase. Think about the classroom that you're in right now. Large classroom. Okay. If you guys were all running around in there, you're going to have plenty of empty space and you're going to exert a certain amount of pressure by running into each other. If I then took all of you and put you in that tiny little closet, AKA I've decreased the volume of our container. Big classroom to small closet. When you are running around in the closet, there's a lot less empty space. And because there is so much less empty space, you are more likely to run into each other. So this is a really key thing to understand, is that when you're decreasing a volume, you're removing the amount of empty space. Therefore, you're increasing the number of collisions, and therefore you are increasing the pressure. So with that in mind, go ahead and think through this question and submit your answer. Okay, so hopefully you said if the volume of a container is doubled, okay, so you're in my classroom and then I put you in the TUI gym, then the particles can expand in twice the amount of space. Thus, the pressure will be less. This is false. If I, again, think about it, there's the, 20 of you running around in my classroom, you're exerting an amount of pressure because you have an amount of empty space. I then take the 20 of you and I put you in the TUI gym. Way more empty space. Way more empty space, way less collisions. Less collisions, less pressure. Okay, so by increasing the volume, you are increasing the amount of empty space. Therefore, you are decreasing the number of collisions. Therefore, you are decreasing the pressure. So it's really important that we understand these relationships. And again, hopefully your mind is starting to kind of think back to all those labs like, was there something where volume and pressure were related? Like, did you change the pressure and a volume changed? Or did you change the volume of something and did the pressure change? I can think of a few. So again, with these ideas, try to link them back to the lab. Okay, so pressure depends on the amount of gas. So thinking about our definition of pressure, the formal definition was, it is the sum of collisions of gas molecules with themselves with their container. Okay. So if I have a lot of collisions, that would mean a lot of pressure, right? Like that, if the sum of the collisions is the definition of pressure, a lot of gas, a lot of collisions, a lot of pressure. Okay? So by adding gas, you're increasing the number of collisions, so you're increasing the pressure. So again, if you think about, you know, when you get a low tire pressure light, often people will swing by the gas station and they will add gas to their tires, right? Or if you have a soccer ball that is slightly deflated, you're going to pump it up. What you are doing is adding gas, okay? By adding gas to your tire or adding gas to your soccer ball, you are increasing the pressure inside that container by increasing the amount of gas. More gas, less empty space, more collisions, more pressure. Okay? So increasing gas, less empty space, more collisions, more pressure. Last thing to think about is how volume and temperature are related. We definitely saw some of this in the lab, right? You definitely had some temperature notes, hopefully, in your observations about hot versus cold. So I kind of really wrote this out for you here because I wanted it to be something that you just kind of truly had. So it says increasing the temperature of a volume makes them move faster, right? So increase in temperature, increase in energy, increase in movement. As the molecules move faster, they encounter the walls of the container more. And so if you're talking about something that's rigid, something that's hard, then that volume doesn't change, but pressure will go up. Whereas if you have something that is soft, that is malleable, so think about like a balloon, for example, okay? Maybe a sample of gas, you know, can get hotter. It's going to make a balloon inflate and get bigger, because the gas molecules are having more energy, more collisions, so they're literally pushing the container out. A fun activity you can try at home is simply blow up a balloon and put it in your freezer. And then if you go and look at that balloon later, it should be smaller because those gas molecules are now low energy, so they're not colliding, so the balloon sort of collapses, okay? So volume and temperature definitely have a direct relationship. High temperature, high energy, high movement, pushing the walls of the container out, bigger volume. Low temperature, low energy, not moving as much, not pushing the walls of your container, balloon might deflate. Okay, so that's what we see there. So those are your big relationships between volume and pressure and temperature and amount of gas. They all influence each other in different ways, and sometimes, you know, temperature might not be involved, right? Like temperature was not involved when you were using the syringe with a marshmallow, right? There was no temperature there. The other thing that's going to come into play for a lot of this is atmospheric pressure. Okay. Atmospheric pressure is exactly what it sounds like. It's talking about the Earth's atmosphere exerting pressure on us. So we don't notice atmospheric pressure when we're walking around. We're not like, oh gosh, it's just so heavy, so heavy. But you may have heard people talk about heavy air, or you may have heard, you know, like athletes travel to Denver early to adjust to atmospheric pressure, or people talk about altitude sickness. All these things, when you are changing altitudes and changing where you are in the atmosphere, you might feel it. Your ears pop during takeoff and landing when you're flying, or if you're a scuba diver, the bends, right? That's a big thing. Or even just normal people. If you've ever dove to the bottom of a pool, you may have been like, oh crap, right? Like these are all changes in atmospheric pressure. And it's just caused by the pressure in the atmosphere exerting force on objects. And that's what it is. And we use a barometer. That's the name of the tool. To measure it. And we'll watch a TED Talk another time about barometers. That's pretty awesome. But yeah, so atmospheric pressure is constantly bearing down on us. And what is important to note is that the lower the altitude, the more air, right, that there is. So low altitude, greater atmospheric pressure. High altitude, less atmospheric pressure. And if the atmospheric pressure is greater than what's inside, you can feel it on you versus the other way. So like the potato chip bag, when you go up in an airplane expands because the pressure in the bag is greater than the pressure on it.